Section we have is to look at the relationships of arcs and find the equations of arcs, sectors of a circle, and minor segments in terms of radians and the angle theta. So basically what we want to do is prove this result L is equal to R theta, where L is the length of the arc, and given that the radius of a circle is r and theta. So if we look at the idea of a circumference of a circle, this circle here would have a circumference of 2 times pi times r, 2 pi r. We know that's the circumference of a circle. This arc here is subtended by the angle theta. So if that's the case, theta on 2 pi would be the fraction of the circumference that the arc encompasses, because it takes out theta out of 2 pi there. So if we get the fraction of the whole circumference as theta on 2 pi, our 2 pi's cancel and leaves us with r times theta, which there's our formula that we need to remember. We do the similar thing for the area of a sector. Now we know the area of the whole circle here would be pi r squared. The sector we want to find is this one, cut off by the radii and the arc here. And we know that encompasses theta on 2 pi again of the circle. So if we take that fraction of the area of the circle, our pi's cancel, we get pi theta times r squared over 2, or we could write it as half r squared theta. There's the proof that the area of a sector is a half r squared theta. Area of a segment, or really the minor segment here. Now the minor segment would be this area cut off here. So it's cut off by the chord going through AB and the arc. So this area all in here would be the area of our minor segment. The other part would be the area of the major segment. But the formula here is going to allow us to do that. If we get our area of a sector that we just proved, half r squared theta, minus the area of this triangle, which would be a half times a times b times sine of this angle, then we can get the formula of a half r squared outside of theta minus sine theta. Remember, our angle is always in radians. If you don't put it in radians, you're going to have a problem, because you won't be able to get the correct answer. So you can't leave it in degrees, it must be in radians. And there's the proof of those three formulas that you're going to have to use throughout the trig functions